Go outside tonight and look at the moon. Then look at it next week, next month, next year. You will always see the same face, the same craters, the same dark patches, in the same arrangement. Every human who has ever lived saw that identical face. Not one person, in all of history, ever glimpsed the far side of the moon with their own eyes. We only saw it for the first time in 1959, when a Soviet spacecraft finally flew around the back and sent home photographs of a landscape no human had ever laid eyes on. Now this raises a question that sounds simple, but hides something deep. For the moon to keep one face pointed at us at all times, it cannot be sitting still. It has to be turning, spinning at exactly the right rate as it circles the Earth. And that precise match is not a coincidence. It was forced into place by a slow, invisible process that is still reshaping the Earth and Moon today. First, let's clear up the most common misconception, because almost everyone gets this wrong. People assume the moon shows us one face because it does not rotate at all. But that is exactly backwards. Picture it. If the moon truly did not spin, if it kept a fixed orientation in space while orbiting the Earth, then over the course of one lap, we would see every side of it. The front, then the side, then the back, then the other side, all the way around. To keep one face aimed at us the entire way around its orbit, the moon must turn once on its own axis for every single lap it makes around the Earth. You can feel this yourself. Walk in a circle around a friend while always looking at them, and by the time you return to the start, you have turned all the way around exactly once. The moon does the same thing. Its day and its year are locked to the same length, about 27 days each. The question is, why would those two numbers ever match so perfectly? Think about how strange that match really is. A moon's spin rate and its orbit are, in principle, two completely independent things. When the moon first formed, billions of years ago, there is no reason they should have lined up. In fact, the young moon almost certainly spun much faster than it does now. A day on the early moon might have lasted only a few hours, so it would have whirled through many rotations for each trip around the Earth, showing us every side in turn. So the moon we see today, frozen with one face toward us, is not how it started. Something had to reach out across 250,000 miles of empty space, grab hold of a spinning ball of rock, and gently, patiently slow its rotation down until it clicked into perfect step with its orbit, and then hold it there. That something is gravity, but gravity working in a subtle way most people never think about. Here is the key idea. Gravity gets weaker with distance, so the Earth does not pull on the whole moon equally. It pulls a little harder on the near side of the moon, the side facing us, and a little weaker on the far side. That difference stretches the moon ever so slightly along the line pointing toward Earth, raising two small bulges, one on the near side, one on the far side. Now watch what happens while the moon is still spinning too fast. As the moon rotates, it tries to carry that near side bulge along with it, dragging the bulge slightly ahead of the Earth-Moon line. But the Earth's gravity is still pulling on that bulge. And since the bulge is now running ahead, gravity tugs it backward, against the direction of the spin. It is like a hand gripping the edge of a spinning top. That backward tug is a brake. Every rotation, the Earth's pull on the leading bulge steals a tiny bit of the moon's spin energy, slowing it down. So the moon's rotation slowed and slowed over hundreds of millions of years. And here is the beautiful part. It only stops slowing when the spin finally matches the orbit. Once the moon turns exactly once per lap, the bulge stops being dragged ahead. It points straight at the Earth and just stays there, perfectly aligned. With no more offset, there is no more sideways tug, no more braking. The moon has settled into the one rotation rate where the forces balance and leave it alone. This is called tidal locking, and it is not some rare quirk of our moon. It is the default fate of almost every large moon in the solar system. The four big moons of Jupiter, the giant moon Titan around Saturn, Nearly all of them keep one face permanently toward their planet, each one braked into place by the very same tidal process over the age of the solar system. One face forever is simply what happens when gravity has enough time to work. But here is the part that brings it home. The moon is doing the exact same thing to the Earth right now. The moon's gravity raises bulges in the Earth too, and you already know them by another name. They are the ocean tides. The water rises on the side facing the moon and the side opposite it, and as the Earth spins underneath, those bulges get dragged ahead, and the moon pulls back on them. That braking is slowly stretching out our day. Every 100 years, an Earth day gets about 2 milliseconds longer. Hundreds of millions of years ago, a day on Earth was only about 22 hours long. And there is a flip side. As the Earth loses spin, that energy has to go somewhere, and it pushes the moon into a higher orbit. The moon is drifting away from us about 3.5 centimeters every year, roughly the rate your fingernails grow. Given enough time, the Earth would eventually become locked to the moon too, though that lies so far in the future that the sun itself would burn out long before it ever finished. So the unchanging face of the moon is not a coincidence, and it was never a sign that the moon sits still. It is a monument to deep time, the finished result of a braking process that took hundreds of millions of years, powered by nothing but the gentle unevenness of gravity across the width of a world. And that same process is quietly at work above your head every single day. Every tide that rolls in and out is the visible edge of it, slowly lengthening our days and nudging the moon away, one fingernail's width at a time. The next time you see the moon, remember that you are looking at the only face it will ever show you, and that the reason why is written in the tides. This has been Actually Rendered, where we show you how things actually work. If this changed how you look at the moon, you know which button to press.